The hot stuff has to lose energy to the cold stuff. Red to blue makes all purple. That's how come TF is going to be the same. So the hot stuff has to be negative. And then you just got to do a bunch of algebra to get to this point. Okay? Today is Wednesday. Your test is on Friday. Tomorrow I have a big chunk of time set aside for work time. So you can plan on, if you would like to use that time to do your test review. Maybe you've already done it, but you will have at least 30 minutes or so just for work time. So tomorrow, if you want to plan with your availability, yeah, let's do test review in class tomorrow. Go ahead and do that. Otherwise, you will have plenty of gas homework because we're going to learn a bunch today, but we won't come back to gases until Monday. Do you know what I mean? So like that homework really doesn't need to be done all the way till Monday. So your choice on that. Can you get out your notes though? We're going to learn some things. Learning. We are learning.
Wow, you're smart, aren't you? What did you? Yeah. Okay, 36 on my ACT.
You have to take it twice to get a 36.
Yeah, I know.
You have to take it twice to get a 36.
If you get a 36, they make you take it again.
I thought it was.
So I'm not purposely going to get a 35.
36 is a perfect score.
What if you get a 35? That's 100%.
Maybe
Yes.
more guys
No, it's just
5
like
times they can't retain if you've had purposely get questions wrong.
I think it's only twice.
Yeah.
Why did he?
Okay, so you know how we are always trying to identify the unknown. So we've solved for molar mass. We solve for molar mass, and then from there we can figure out what the unknown is. Again, we're going to do it again. Things are cycling back around. For gases, though, it's way easier. You can just rearrange the ideal gas law, and you come up with this equation here, and you just have to plug stuff into it. So to solve for molar mass of a gas, it's dRT divided by P. D is for density, and the unit is weird, though. It's grams per liter, so probably not going to give you grams per liter. You're going to have to convert it to get to that. R is just our regular 0.08206 liters, atmospheres, Kelvin moles. That's a derived unit, so it comes from externalization. Temperature has to be in Kelvin, and pressure has to be in ATMs. These are super nice problems. It's just maybe you have to convert one or two things, but just plugging them in. Oftentimes they're 2 points because they give you a point for converting and then a point for plugging in. So easy money on that. We're going to do a sample problem on that one. Dalton's law. Oh, I'm going to use colors, so get out your colors or come get colors.
Grab one yourself.
I'm red and green.
Oh, perfect.
I know, it's perfect. Actually, I'll switch it up. Can you see red and blue different?
What?
Is red and green the same?
Yeah.
Okay, so should I do red and blue? Can you tell that?
Yeah, I did.
Okay. All right. Draw some red gases. They have zooming lines, obviously. Draw some blue gases with zooming lines, obviously. The blue gases crash into walls. That creates pressure. The red gases crash into walls. They're called boinking. That creates pressure. Yep. If that was a balloon, that would keep the balloon inflated. The boinking does. Oftentimes, we have a mixture of gases. Like right now, we're breathing a mixture of gases. Very rarely is something going to be a pure gas. So our total pressure of all these collisions is going to be the pressure of the red gas plus the pressure of the blue gas. And then there's a vocab word that goes with that. These are called partial pressures. Like, if I could just see how much bunking the blue one is doing, that would be its partial pressure. If I could just see how much the red is bunking, that would be its partial pressure, and it adds up. Oops, lowercase n. The number of moles is also the same. I could separate out how many red ones are there and how many blue ones are there, and add them together or keep them separate. I didn't mean to scooch it that far. I hope you're caught up. Sorry. And then I can do this. If I just took the red, I can use PV equals nRT, but then I also need to make sure that my number of moles is just of the red. So my pressure of just the red, my number of moles of just the red, and I could do the same thing for the blue. So it just kind of depends. Reading comprehension, what is it giving to us? Is it giving us a mixture? Is it giving us a pure gas? Okay. We're going to write some more things. Oh, did I go too far again?
Maybe we'll just take in all of those notes in pen, or red pen.
It's fine. Stop making fun of the genetic change, variation.
Trigger, was your birthday like this weekend?
It is?
Happy belated birthday.
Yeah.
Let's sing.
Okay. Oftentimes, when you do these mixtures, you know how, like, when we practice with the last unit, like, what words are we looking for so we know what to do? The words you are looking for is displacement of water. Gas collection by displacement of water. Okay, so now you're going to have to think back to honors chem or baby chem. Remember the experiment where you took a piece of magnesium and you used the UDiometer tube, and then you flipped it and it made all these bubbles, and it made like a bubble tube?
Yeah.
Okay, so there is water. That's blue. Water is blue to me. There's water at the bottom of a tube. Just because water can, some of those water molecules are going to evaporate. These are gas particles with semi-lines evaporating off like the water line. Okay? Gas water has a special word. It's called vapor. Okay? So now we have a pressure, because they're going to bond here and they're going to bond here. We have a pressure of just the water. When we do gas collection, displacement of water is how we can measure. So this is like an experiment. Oh, this screen. This is an experiment. So the experiment creates these bubbles. So those bubbles also are going to have a pressure. Probably. Oh, geez, that's not that.
See if I had my little
Yeah, I need to make it.
Yeah.
I thought you said you would make it for this.
Cool. That's what we're making tomorrow in 30 minutes. Okay.
I still didn't get to it. I'm sorry. Okay. So when we have displacement of water, we automatically have water pulsate, and we automatically have a pressure of what our experiment is about, and we're going to do a sample problem with that. The very last thing I have to show you is something called mole fraction. Mole fraction is just a proportion. Super simple.
It's H2O plus 2 equals.
Wait,
P H2O.
H2O. What? P2 equals P total. P.
Yes.
You look like this, Cole?
Yeah.
Why is that?
Oh.
It's like.
Like the X fancy, you can just write that.
The X is kind of a fancy X. It's called chi. It's a Greek letter. Is that? Am I right? Chi squared. Yeah, like a chi-squared analysis. That's called chi.
So excited about that.
So it's equal to. It just shows. It just shows that the proportion is equal from moles to pressure. Makes sense. More red molecules bonking is proportional to the pressure of the bonkingness. More blue molecules bonking is proportional to the pressure of the blue molecules bonkingness, right? Obviously. Okay, let's do sample problems. I'm turning the music on so you can get your talking out before we do sample problems. The point of the music is to give you a chance to talk, so you shut up when I teach. Ready? Set. Owen, you better talk this entire time. Go.
I can't sing it. I was screwing too loud.
Okay, PV equals nRT. Go ahead and plug stuff in. Remember, pressure has to be in ATMs. Volume has to be in liters. Number of moles, this one you are. Given number of moles, kind of easy, but not usually. R is the universal gas constant, 0.08206. 0.08206 liters, atmospheres, kelvins, moles, and your temperature has to be in Kelvin. It's a derived unit. 273, which is degrees Celsius plus 273. Okay, with your bad buddy, plug it in and push your button. Oh, a sample of nitrogen gas. Gases are diatomic. So not nitrogen ion, that's like floating around in water with water molecules and dipoles. Nitrogen gas are like bubbles. Bubbles are diatomic. Has a volume of 1.75 liters. I'm a bad reader, so I like underline things as I read. STP means that my temperature is 273 and my pressure is 1 atm. How many moles of nitrogen are present? When it's at STP, we can do a shortcut. Only if it's at STP. If you do not want to worry about a shortcut, you have enough information to just use PV equals nRT. Otherwise, you can do this. 1.75 liters over 1 times in the line. Liters on top means liters on bottom. Only at STP, 1 mole of any gas at STP is automatically 22.4 liters. But only if it's at STP can you do that. And if you don't want to worry about that, just plug in 1 atm and 273. You'll get the same answer.
Easy peasy lemon pie.
Yep. Lemon squeezy.
Why'd you say lemon pie? That doesn't make sense.
Is that a 1?
Complete the joke. Yes. That's probably what it is. A real one.
Calcium oxide is produced by the decomposition. Decomposition means we're breaking it down into calcium oxide. Calculate the volume of CO2. Remember, carbonates always make carbon dioxide. So we're trying to find volume here. We're at STP, so we have 273 and 1 atm. And it says produced by the decomposition of 152 grams. You are given enough information almost to do PV equals nRT. You have a pressure STP. You are solving for the volume, so this is your question mark. We do not have moles. We always have R and we have T. So the next thing you need to do is you are never going to be given moles, to be honest. You're going to have to solve for it, okay? But I can. I have grams of calcium carbonate, and I'm really good at doing stoichiometry. So get to your moles of CO2, and then plug it in. I'm going to try to fast forward this. Then do number 3.
Here, I'll take the next song. No,
It's just scratching your back. There are no words.
Good posture. Yeah, right.
The density of a gas was measured at 1.5 atms. Here's your temperature. They gave you the density in the correct units. But watch this. Watch that. It has to be grams per liter. Calculate the molar mass. These are so easy. DRT, regular R, 0.08206, divided by P. It's just a rearrangement of the ideal gas law, which makes it super easy for you to limit squeezing. Plug it in and push your buttons.
R. What's
We are so excited to
Wait,
announce
08206.
our customers baby furniture from the
Because that's what R is.
It's a derived.
A deep sea diver uses a gas cylinder, we're drawing a picture, with a volume of 10 milliliters. Oh, liters, just kidding. It has oxygen and helium, so we have the mixture of gases. That creates partial pressures. The bunking of the red is separate from the bunking of blue if you wanted to. Calculate the partial pressure of each gas and then the mixture at 25 degrees Celsius. So we're just going to use our regular PV equals nRT, but make sure you match red to red and match blue to blue. Okay? You don't have moles, but you can easily get to moles. You're at grams. So divide by molar masses and then plug in.
You scroll up by like 0.1.
Mole fraction is your total moles. Oops, just kidding. Your partial moles over your total moles. This is like what we were just saying. The amount of stuff will give us our pressure. There is no units to this. It's just like a percentage minus the percent part. So it says, there is a vocab thing that I have to tell you. The partial pressure of oxygen was 156 torr with an atmospheric pressure. That is code words for total pressure. Atmospheric pressure is total pressure. Okay? So if the barometer reads an atmospheric pressure of, that's total pressure. So our mole fraction, it doesn't matter that they're in torr as long as they're the same thing. Because it's just a proportion. Okay? But the takeaway is atmospheric pressure is total pressure. Okay?
So does this mean like that oxygen took up like caused 156 of the 743 moles?
Yep. And it's proportional to the number of moles.
William.
Cool.
Because of the gas law constant.
Let's push.
Do you always have to put a zero in front of it?
If you don't, then your reader might not see your decimal. That's why we do.
I always make my decimal obvious.
Okay. Then
You don't.